All right, so today we are talking about we're still talking about angle relationships in triangles, but now we're going to start talking about those exterior angles. And so we had the following problem: and triangular windows of the Alua Medica Conference Center in Sweden are formed by three sets of parallel lines going in different directions. So we have 1, 2, 3, right? So like there's lots of parallel lines going on because I've got these parallel lines, we've got those parallel lines, and we've got these parallel lines. That's what we've got going on. A close-up of the window design shows a triangle. The measures of angle 4 is related to the angle measure of the triangle. How can you use the measures of angles 1 and 2 to write an expression for the measure of angle 4? So we don't have actual angle measures. We're not assuming. Nothing tells us that these are rectangles. We just know that they're parallel lines. We are not going to assume because, as many students will tell you, well, what if it's a 91-degree angle? It's going to look a lot like 90 degrees. So all we're going to do is just talk about what expression can we use to find this. So it talks about, we can picture it, right? Here's my parallel lines. Measure of angle 4 is going to equal 4. They've changed 4, which was in this picture, to angles 5 plus angle 6. So the measure of angle 4 is going to equal the measure of angle 5 plus the measure of angle 6. And then based off of alternate interior angles, right, we know that here's my transversal, there's my two parallel lines. That angle 2 is going to be congruent to angle 5 due to alternate interior angles. And that 1 is going to be equal to angle 6 because of corresponding angles. And then we have the model it that just says I know that angles 1, 2, 3 is 180 degrees. That's what we learned yesterday. The measure of angle 3 plus angle 4, going back to this picture, 3 plus 4 is a linear pair, meaning that they are also going to equal 180 degrees. And since these both equal 180 degrees, I can then write measure of angle 1 plus measure of angle 2 plus measure of angle 3 is going to equal the measure of angle 3 plus the measure of angle 4. And then we would solve it from there. So those are just ways that we could start it. So let's go to the connect it. So first, this is a vocab term right here. So I would do something to make sure that we know. An exterior angle for a triangle is formed by extending one side, of the triangle. Didn't mean to make that one go out so far, but so the exterior of a triangle is formed by extending one side of the triangle. There are two exterior angles at each vertex of a triangle. For example, the figures at the right show the two exterior angles for the one angle of triangle X, Y, Z. Why are the two exterior angles at the same vertex congruent? So here we have our two triangles, right? And here we extended segment ZX, and here we extended segment YX. And it is claiming that both of these exterior angles have to be equal. Why? Well, they both add, like they're a linear pair with 100, right? So both exterior angles with the, add with the 100 is a supplementary angle with the 100 degrees. Therefore, they have to be the same. So both exterior angles are in a supplementary pair with the interior angle. I'm going to put 100 degree angle. Therefore, they have to be the same. Like, there's no way to get around it. What another student said was, well, if I extend them in the same picture, right, then this exterior angle is a vertical angle with that exterior angle. So that's another way to think of it as well. That when those sides intersect, they form vertical angles. All right, number 2. Look at the modelet. Simplify the last equation. What is the relationship between the exterior angle of a triangle and its non-adjacent angle pair? So if we look at the modelet, the last thing they had was angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle 3 plus the measure of angle 4. So to simplify it, well, there's 3 on both sides. So I'm going to subtract the 3 out. Minus the measure of angle 3. So it's going to zero out on both sides. So now I know that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. They are the same because they add together with that same measure of angle 3. And they both add to, both expressions added to 180 degrees. So what is the relationship between an exterior angle of a triangle and its non-adjacent interior angles? And that is that the exterior angle is congruent to the 2 non-adjacent interior angles. That's the relationship. That my outside angle is going to be equal to the 2 inside angles that it is not touching, that it is not next to. All right, so number 3, look at the triangle at the right. Use the measures of the non-adjacent interior angles to write an equation with the measure for each exterior angle. And so the way that would be is like, here's 4, right? So the measure of angle 4 is going to equal the measure of angle 2 plus the measure of angle 3. Because there's 4, I'm not going to use 1, it's adjacent. 2 non-adjacent, 2 and 3. So then if I look at the measure of angle 5, that's going to be 1 plus 3. So that's the measure of angle 1 plus the measure of angle 3. And then lastly, angle 6. Measure of angle 6 is going to be my 2 angles not touching it. So measure of angle 1 plus measure of angle 2. Oops, angle 1, angle 2. And that's how we write the equation and the measure of each exterior angle. Next question. Use the equations you wrote on problem 3 to find the sum of the measures of the exterior angles of a triangle, 1 at each vertex. So here we have 1 at each vertex. And what it's wanting me to do is find the sum. So I'm finding the sum of the measure of angle 4 plus the measure of angle 5 plus the measure of angle 6. And we need to figure out what does it equal. Well, I know about interior angles, so let's start using what we know about our interior angles. I know that the measure of angle 4 is the measure of angle 2 plus measure of angle 3. So measure of angle 2 plus measure of angle 3, right? Right now, that's my angle 4. And then I'm going to add my measure of angle 5. Well, measure of angle 5 is measure of angle 1 plus the measure of angle 3. So I've got measure of angle 1 plus measure of angle 3. And then lastly, 6. 6 is the measure of angle 1 plus the measure of angle 2. So measure of angle 1 plus the measure of angle 2. I still don't know what it equals yet, but I do know that I have all of those. I know about inside angles. I know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 are interior, so they have to be 180 degrees. So now I'm going to basically move my parentheses around, and I'm actually going to make them brackets. Because what do we notice? I have angle 1 plus angle 2 plus angle 3. Well, that's 180 degrees. Over here, I have the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. Well, that's another 180 degrees. So 180 plus 180 is 360 degrees. So the exterior angles of a triangle, only one at each vertex, is 360 degrees. Do you think your answers to problem 2 and 4 are true for all angles? Explain. Well, when we look at 2, and it doesn't matter what the angle measures are, I am always going to have my 3 inside add up to 180, and the 2 linear pair are going to add to 180. So they're going to be equal to each other. Take the angle that's the same. It's always going to be the same. So do you think the answers to problems 2 and 4 are true for all triangles? And the answer to that is yes. And you can put your own explanation with that, but the big answer there is yes, it is true for all triangles. The exterior angle is congruent to the 2 non-adjacent interior angles, and then here the exterior angles of a triangle will add to 360 degrees. Always. I'm not going to make you do the reflected. In the next video, we will go over the review questions. So